Hi guys, welcome back to the shop. Today we're jumping back on the GT1, GT80 Yamaha. We're going to take a look at the cases, kind of do some checks of the transmission, and just get ready to start building this thing. I've got a set of cases. I'm sure there's a lot of people out there that know more about this stuff than I do. I'm just going by what I see and the information that I got online by just looking at different models of cases, like on eBay or whatever. And that's where I first found out that this crack thing was not an isolated thing, because I looked at two sets of cases and they had the same identical crack in the same place. So I knew something was going on. And I just started looking at newer model cases, and it didn't take me long to find a 74, what they said was a 74, and saw the beefed up bushing area. So it's just what I could see and what I could figure out from what I was looking at there. So it looks like probably if the people that listed these listed them correctly, that probably in late 74, they started beefing up these cases. They knew they had a problem, and all the ones that I saw that were later, none of those were cracked. So that probably fixed the problem. So let me get you overhead here. We'll take a look at what I got. I'll show you what I'm doing with the transmission gear shafts just to make sure they're okay, and we'll start building it up. Okay, I got the new and the old setting here, and right here is the crack in the old, and you can see there's not much webbing around this. And here's the case I found. It has this radial webbing. Let me get you a little closer. You can see the radial webbing here. That's not on the other one. And I looked at the in the IPB for this model, and from 73 way on up, like almost 80, I think, all these shafts are the same length and everything, so they use all the same parts. I think there's I don't know, it seems like there's some place along the line they go into a 5-speed or something, but we're not dealing with that. This is a 74 case as listed. It might be newer, I don't know, but it has the beefier bearing boss there. And if you look at the old one, you don't see any of that. You just got this one coming over to the center bearing, this one here, and this kind of, I don't know what this was for. The other one, the new one's got it too. And on the new one, these reinforcements go into here and then down to here. So they really beefed this up. So you can see here how this goes into this and here, and then this is a thicker one than the one that was used on the original case, and I just think this is going to be a lot more strong. Let me flip these over now. See, I don't think there's a whole lot of difference on the inside. This again is the new one. Everything pretty much looks the same in here. I guess these were oil, to let oil run down in and get around the bushing. That's probably what all that was about. But this one, the original one, of course, you can see the crack here. And the crack on the outside here going into that web. And do note too that the damage here to the kicker. And you go to the new one, and there's a little bit of mushrooming starting right here, but there's nothing broke out yet. So I think this is going to serve him well for a while. I just think this will work real good. This is actually from the Trials version. I can't remember what they call it. TY, I think it is, a TY80. But since we're using only the right-hand case and we're able to keep the serial number, then this should work fine for him. I've already stuck it together with the dowel pins, and it seems to be a perfect fit. So it shouldn't be any problem. These cases are sold separately by Yamaha, so they were intended to be serviced separately, not as a pair. All right, this new case doesn't have the pivot for the shift mechanism, so we've got to get it out of the old case. This one probably didn't fit real tight, and I think everything else is in there, but we've got to get this out of the old one. And first thing I'm going to try to do is just heat it up, see if we can get that to pop up there, pop out. There we go. Okay, I've got the counter shaft over here in the lathe, and there's very few places that you can really check anything on it. So it's going to be a little bit jerky in places, especially on this end. But as you can see here, I'm running right over the that spacer right there that's made on the shaft. And I'm not getting any more than a half thou deflection on that. Let's see, we go down here to the smooth bearing surface, and there's nothing there. And we go down here. When we hit the groove, this groove right here, when we hit that, we get a deflection. Other than that, it's within a couple thou. Run on down to the end here. And again, we hit the groove right here, and we get a deflection. Otherwise, we are within a thou. So I'm satisfied that's not going to bind up, and it should work just fine. So I've got everything laying out here. We're just going to go ahead and put it all back together. Okay, so we've got a snap ring and a washer on the first one, or a washer and a snap ring, and then just a snap ring on the second one. And then this one comes in and goes into that one. This one then goes on to here, like that, and it gets a washer. and a conventional snap ring. Okay. Okay, the other shaft lends itself to doing this without taking the gears off. And we're within a half thou there. And the same half thou there. And again, we've got a groove over here that we have to contend with. Actually, we don't right, yeah, we do. Yeah, right here. So it's within that half thou until we get to the groove. Get a little more preload on that just to make sure. Yeah, just the groove there and the groove there. And that's almost the center of the shaft, if there was anything. But this one really isn't the one in question. It's the counter shaft, and we're within a couple thousandths anywhere on that one. So I don't see any problem with it either. Okay, we just heat up our casting there and get our bearings in. Put a little blue Loctite on the retainer. These are actually coming from Yamaha these days with this rubber seal on it instead of the metal one. I usually get my stuff from a bearing house. It's a little cheaper than the Yamaha stuff. And it's the same stuff. You can still get the same bearings. These are Koyo. I'm going to give that a little pop. With my impact. I'm on my rubber covered bench here, guys. Heating the cases up. Heat gun works pretty good for this, actually does. Might have to tap them a little bit, but if you get them square, that's the main thing. Okay, it's pretty hot yet, but you can see that it's right up again the boss here, seated all the way. You got your oil hole right there. And if you notice, I'm putting these bearings in numbers out. That one's seated good, I believe. Let's take a look at it. Yep, completely seated. And let's get these seal areas cleaned up. It's still got a little bit of remnants from it being melted. That's good. Okay. Again, most people don't do this, but I like to do it. You actually have to work at getting them out when you want them out. They'll still come out. And if they're a little tight, just put a little heat to them, and it takes care of it. See, these just push in. Okay, just like that. I don't have this one yet, so I'm going to leave that one in to make sure I have one before I remove it. I think that's the kicker. That won't go in there, so this must be the one for there. Yep, okay. It's pretty much self-explanatory. Okay. Okay, so we're ready there. We have one seal to put in here. And I'll go ahead and, now again on these, you see the numbers on the outside. If it doesn't tell you to put it a certain way, Yamaha says to always put the numbers out, looking at you when you put it in. If you remember right, when we tore this one apart, that seal was about in that position. So, believe it or not, this is what keeps that from happening, unless you've got a retainer. Some of the, with the AT1s and CT1s, they at some point did come out with retainers. Some of them have them, some of them don't. Again, just kind of clean that area that you're going to apply the seal to with some lacquer thinner or alcohol. I use acetone. And the numbers are out facing me right now, so I don't think it really matters on these. It's a double lip seal, I think with a double spring too. So I believe it can go either way, but that's what, I've got a couple books, service manuals from Yamaha that's what they say, is to put them in with the numbers out, unless it tells you otherwise. Okay, now we need to find out what our case capacity is as far as bearing to bearing. Now make sure your bearings are seated for this. I've got a half-inch parallel that is actually 2/1000 over. And you just measure down to your inner race here, across the and I've got 1.255. So make a note of that. Get our other one out here. The same procedure. And that one is about 1.256, we'll call it. It's a half thousandths over 5. So we'll call it 6. So that we know. So we've got 1.256, 1.255, gives us a total of 2.511, and our parallel is two times is 1.004. So we subtract that and we get 1.507. So our case total is 1.507. The crank we measured at 1.494, which is almost 38 millimeter. And that leaves us a clearance of 13 thousandths, 0.338 millimeter. So we've got 13 thousandths in there, so we don't have a lot of room. You really need to be at that 38 millimeter. That's what you need to be at. No more, no less. You can be less, but you don't want to be any more. So that's where we're going to have to go with our crankshaft now, is we've got to figure out by putting the shims in. Okay, here's the shims for the later model, I think 77 and up. And they are right at 1 millimeter, 40 thousandths. Okay, so we've got to make room for those. That's our main objective. They're going to go right here. So the common thought would be that we need to remove a millimeter from each one so we can put these in there. Let me get you over to the milling machine and I'll show you what I'm experimenting with. Okay, this is what I've been setting up, trying to proof out what I want to do. I don't have the equipment to put it in the 4-jaw chuck. It just doesn't offset me enough to do this. So I've got to do it this way, and I'll offset the boring head in order to do this. But right now I'm getting everything leveled up, and I've already got it centered as far as the hole goes. So this was the side that had some wear on it. So that's the first thing I want to do is clean this up. But I'm still experimenting with this and trying to measure everything out. I think that I need to remove a millimeter from each side in order to get this to work. So that's where I'm looking right now. Okay guys, I've mocked up my crankshaft here. I've actually spun a pin out of aluminum to just be a snug fit, not a press fit. And I put my rod and my 2 thrust washers and the bearing and 18 thousandths shim. That's what the clearance is supposed to be. And I just wanted to see if I'm on the right track here. And we're right at 40 millimeter with all that put together. And remember our what we took it apart as was 37.99 and 38.07. So I'm satisfied the correct width should be right at 38 millimeter. So if we take the 2 millimeter out for the shims on both sides, we should be good to go. Right here. I just wanted to visualize it myself. That's what it should seem, what it seems like it should be. Now this is the worn side here. So this is, we're going to call this the the height that it is now. It's lost quite a bit here. I don't know, 2 or 3 thousandths probably. So we're gonna take off our 2 thousandths, or I'm sorry, not 2 thousandths, our 2 millimeters, actually 1 millimeter per side. We'll take that off from here. This side is pretty much unmolested, so we'll just take it off as it is. And we'll do that with, so I can check it this way with a depth mic. So I feel pretty confident. You know, the dimension as far as, I think it's 17 to 19 thousandths is what the clearance is on this. And that dimension was built into it before. So all we should have to take out is this. And like I think I showed you before, those are 1.01. So if you get all that assembled, and we make sure that our pin on this side stays flush with this area, not here, because if it comes out, I mean, it can come out here, but it can't come past it. You know, so I just figure being flush here, and I made this pin the same length as the pin that's going to go in there. So you can see here that we've got quite a bit of recess. So there's our 2 millimeter. So that, once we assemble this and take off the 2 millimeter total in there, then this pin will be out just like this one is. So I feel we're good by just taking off the 1 millimeter from each side, and we won't lose anything as far as the dimension here, you know, our clearance, because we're going to put it back in with the thrust washers. I just think the thrust washer is a better idea than just putting it in there bare like they did. And obviously they do too, because they changed it at some point. Okay guys, I just want to slide these two cases together. I got the transmission in here, and I just want to make sure that we're not going to have any binding. There it is. No binding. Remember before I could turn this about halfway and then it would get real hard. But it's smooth as it can be. Okay, I think we're good. Looks good. 4 gears. Thanks, guys. Okay, guys. I tried the experiment here, and this is an old Suzuki crankshaft that is absolutely no good, so I wanted to try it on it first. And you can see in this case, right here in the middle, they've induction hardened this. I can, a file just pretty much glances off of it, whereas over here, I can go ahead and file that, so it's not hard. So it stopped me from going down. This is high-speed steel on my mill, and it's just not going to go. It's going to take carbide or at the very least cobalt to cut that. But all is not lost. So let me show you what I'm talking about. Okay, I don't think this one is hardened. I can take a file on the edge there, and it files right into it. So I do believe this one will be able to do like that. So all is not lost. I think we can still do it, but I'm not going to be able to get it into this video. I've got a lot into it. So we're probably going to call an end to this one and just press on for another day. I think this one will work okay with high-speed steel. If a file will cut it, it should. Yeah, I've tried it up here on top. It cuts it there good, and down into the hole. So I think we'll be okay with that. So we'll get this set up in there. It just that I couldn't believe that that Suzuki one was. I guess that's what they did, was induction harden just where the pin goes. It was cutting around it, but not in the hole. And that's why I wanted to check both places here, up on top and in the hole. We just need to take that millimeter out here, about 40 thousandths, and we should be good to go. Okay, guys, there you have it. I never in my wildest dreams thought that'd be hardened in there, but I think we're okay with the one that we actually need to do. This was just an experiment on my part, just to see how the finish was, and just to see if it was going to work. And I think it will. We'll just have to get the other one bolted up in here and see what it does. But we've made quite a bit of headway. We've got those cases ready. We've verified that the transmission shafts are straight. We've actually even put them in the case. They turn freely. So we've done a lot of prep work. The bearings are all in, the seals are all in. So it's ready to build. All we need to do is build a crankshaft. So the next time you see this one, we'll probably be doing this, unless the file is telling me it will cut it. But whether it will or not, we won't know until we get to the point. But I think it will. So probably the next time we see this machine, or we work on this machine, that's what we'll be doing. I don't think we'll get the crankshaft built in the same video, but we might. We'll see. You guys have seen me build a lot of crankshafts. This one's not going to be any different. It's going to be just like all the rest of them. So maybe I can do the cut and do an abbreviated build and an abbreviated check for runout and be done with it. But we'll see. Anyhow, we made a lot of headway on this, and I think we're ready to go. Hey, thanks for going along on the ride. See you next video.